In this lesson, we're going to go back a couple of months here when we first learned about moles and molar mass. So this time, though, we're going to talk about compounds and how we can apply molar mass to them. First of all, the mole, this is the unit to represent particles, right? So you can kind of do this in a couple ways, but, we'll say, first of all, amount of matter, but really it's about the large number of particles in a sample. Right, so whatever it might be, if we talk about the mole, we're basically saying how many particles are in a sample. So 1 mole is lots of particles, 2 moles is even more particles, and then we can just kind of sort of use the word amount of matter, but really think about this as the particle count. First of all, 1 mole, that's going to be 6.022 times 10 to the 23rd particles of some kind. You'll be expected to use the appropriate particle for the appropriate substance. But for now, then, broadly speaking, we're just saying particles. That is also known as Avogadro's number, right? Now, of course, this is not Avogadro's number. Make sure you get the term down for Avogadro's. And of course, these particles can be anything: atoms, ions, electrons, molecules, forming units, bananas, whatever it is that you can actually count. We can use the mole for it. The next term for review, molar mass. Molar mass. This is the mass of 1 mole of any substance, right? So it's the molar mass. Please remember, it's in the name, right? Molar mass, it's the mass of 1 mole of substance. For elements, the molar mass is the same as the, if you remember this, atomic mass of the element. So kind of thinking back a little bit to a long time ago, that number, the atomic mass, that's that decimal number, that one that's underneath every element symbol. So kind of looking back at these, basically anything that's down here, right? All these are going to be your atomic masses. Then what about the next one? For compounds, the molar mass is the sum of all atoms of each element in the compound. So basically, we're talking about not just a single element now, we're talking about groups of elements for compounds. So basically, add them all up, that's the molar mass for the compound. Using the atomic masses from the periodic table. So if you remember, there's a bit of a policy we're going to take with this, right? There's lots of numbers that you can, again, potentially copy from the periodic table. But when it comes down to it, it's going to be easier for us to come up with a way to sort of manage these numbers so they're not so overwhelming. First of all, we can either round to 2 decimal places, right? Or, right, round to 4 sig figs, whichever one gives you more to work with, right? So we don't want to limit our calculations because we take too few numbers off of the periodic table. And so you want to make sure you take these molar masses accurately from the periodic table, or at least in a way that is going to be useful to your calculations. All right, quick couple of examples here. What's the molar mass for each of these elements? Iron, nitrogen, and oxygen. All right, just to review here, let's go and poke back over to a periodic table. Our friend iron, Fe 55.845. Now, what we're going to do is we're going to look at either taking 2 decimal places or 4 significant figures. So 2 decimal places is 55.84, at least at that place. And then 4 significant figures is 55.84. So 1, 2, 3, 4, also at the same spot. So we're going to take that number, of course, we're going to round it as well. So instead of saying 55.84, that 4 gets rounded up to a 5 because it is a number greater than 5. So 55.85. And of course, we have grams per mole. That's going to be iron. Right? 55.85 grams per mole. All right, nitrogen, again, poking over here to the periodic table. Let's go ahead and look. Finding nitrogen, 14.00674, 2 decimal places, or 4 significant figures. They're the same value. So in this case, it ends up being 14.01 grams per mole, right? Molar mass, grams for every 1 mole. And then oxygen, right? Go ahead and pop that over to the periodic table to see what's up here, 15.9994. And then this guy right here gets rounded at this position because 2 decimal places and 4 significant figures end up at the same spot. So this rounds up to 16.00 grams per mole. Okay, so to be clear, right, these can also just be written or thought of as 16.00 grams of oxygen for every 1 mole of that oxygen. And that there, again, becomes a useful relationship that we can use in a later calculation. Example number 2. What is the molar mass for the compound iron 2 nitrate? Okay, so the molar mass. Now this time, we're not talking about individual elements, we're talking about the compound. So this is all combined into one thing. Iron 2 nitrate, let's see. Well, I got to figure out what iron 2 nitrate is. First of all, we have a multivalent metal. We have the polyatomic ions here. This is a polyatomic ionic compound using a multivalent metal. So we know we have to do a little bit of work here to get the formula. Now the formula is going to end up being Fe and the nitrate because it's a -1 charge to match up with a +2 charge of iron. We need 2 of them. So this is going to be a compound FeNO3, 2. Now, with that, right, we got to get the molar mass of this compound, not just of iron or just of nitrogen or oxygen. So I have to do a little bit of work here. All right, so what do we need to do? Actually, I'm going to scooch this whole thing over so it's a little out of the way, give us some room to do some work. Oops. All right, so for this one, again, we basically have to find the sum of all this together. So that means we got to do some calculations before we can combine it all. So for iron, I'm going to do 1 times 55.85 grams per mole. That's equal to 55.85 grams per mole. Nitrogen, how many are there? There's 2 nitrogen, so 2 times 14.01 grams per mole. That's equal to 28.02 grams per mole. And then oxygen, there's a total of 6 of them. 16 times 16.00 grams per mole. And that gives you a total of 96.00, naturally, grams per mole of oxygen. All right, now again, that doesn't actually answer the question because it's asking you for the entire compound. So we take effectively all of these, this one and this one and this one, and add them all up. So what do you get? Doing this off to the side to kind of give myself a little bit of extra room. 55.85 grams per mole plus 28.02 grams per mole and 96.00 grams per mole. Add all these up, right? Get a total sum. In this case, you get 179.87 grams per mole. Do a little bit of significant figures work, remembering that when you add things together, you round your final answer off where the original numbers have the least amount of precision. All of these end at the 100th place, so your final answer also ends at the 100th place, not because it's 4 significant figures. All right, so with that value right here, this concludes the work we have to do. Frankly, after a little while, I really don't need to see you guys write it out like this every time. If you have this question, what is the molar mass for the compound iron 2 nitrate, and then all you write down is this answer, that will be perfectly acceptable because, again, this is one of the things where I can trust that you can do that work. All right. Now we're going to put this in action. So that number is going to be kind of useful here. We're going to actually see why this works. Partly because these problems here all relate to iron 2 nitrate, right? So the same compound. But also, if you notice, right, if in this little, these kinds of problems here, they're asking you about grams of iron 2 nitrate, something about mole amounts of this compound. And a lot of this stuff can be a little bit confusing if you don't have a way to keep track of it. So we have this little diagram right here to help you organize your work. Notice that in the boxes, you have mass, moles, particles. Of course, particles can be replaced with whatever particle you need to. And then between them, you have little things right here to help you keep track of what you need to apply to get from one unit to the next. So if you want to go between mass and moles, you apply molar mass. Units, of course, are grams per mole. Or if you want to go between moles and particles, we're going to use Avogadro's number, Avogadro's constant, and then the units are going to be whatever particles per 1 mole as well. So using this logic, right, we can go ahead and tackle these problems at the bottom. The question is asking you for a gram amount of iron. It's giving you 3.4 moles, so 3.4 moles of iron nitrate. We want to go ahead and convert that into mass, right? They're asking for mass, so we need to apply the molar mass. What's the molar mass of iron nitrate? Well, thankfully, we figured it out over here. It's 179.87. Of course, that as it's written is probably not the most useful way to represent the molar mass, so you might want to rewrite it like this just to give you that visual to work with. 1 mole of FeNO3, 2. And then we basically apply it as needed. So looking at this work, right, if we have moles up top here, we need to make sure we cancel off with moles on the bottom here. And as this is written, you can go and stick it in. So 1 mole of FeNO3, 2. And then the molar mass, or at least the mass that goes with it, 179.87 grams of FeNO3, 2. And there you go. That's how you do some work. Your calculator will give you a number like 611.558 for this one. And checking our significant figures, this one has 2. This one has 5. This one right here is infinite. So with multiplication and division, we look at the value with the least significant figures, and that's how we round our last answer. So 611 point yada yada yada. This one then gets rounded to just 610, right? This one gets rounded down. 610, 610. And of course the units here are grams of iron nitrate. All right. Again, all we're doing here is applying conversion factors. These conversion factors come in the form of molar masses. Molar masses can then be flipped upside down as necessary to be able to solve for what you need, applying the same old rules for significant figures and such. You'll find that this is more or less the same thing we've been doing before. Let's go and work out these last two just to make sure you get a sense of what's up. The question is asking a sample is known to have this many formula units. By the way, formula units, that's the term that's used as a particle, representative particle for ionic compounds. How much mass is in the sample? All right, so in this case, we're given a particle amount, and we're being asked about a mass amount. How do we go from particles to mass? Well, first I need to apply Avogadro's number to get it to moles. And then once I have a mole amount, I can apply molar mass to then get the actual mass. So this is going to be a two-step process. Let's see how it looks. 4.55 times 10 to the 20th. Formula units of iron nitrate. I'm going to apply Avogadro's number, and that was not a very straight line. So then we go ahead and do 6.022 times 10 to the 23. And once again, we're going to apply the appropriate constant or appropriate unit for this compound. So in this case, it's formula units, and that's equivalent to 1 mole of iron nitrate. So that way we know when we do the work, we're going to cancel off formula units of iron nitrate, formula units of iron nitrate, right? Because they're on opposite sides of the equation. And then we can get moles out, but we're not quite done yet. So let's keep this going because this only gives me a mole amount, right? This only gets us from particles to moles. Let's go and finish it up by applying molar mass to get to mass. So for every 1 mole of FeNO3, you're going to have a molar mass of 179.87 grams of iron nitrate. All right, so that's your basic setup for this problem. You have all that writing to do. However, again, it's just a little bit tedious, but only because you know that this is a straightforward process. We can apply these conversion factors. And to finish off this one, right, moles of that, those cancel. All you have left are going to be grams of substances. Stick these in your calculator. One quick reminder, don't forget that this involves dividing by in scientific notation, so make sure you put parentheses around what you need to divide by. And then you do some math, doing some significant figure calculation or work. Right? We have a division multiplication, so we care about the number of sig figs. That one has 3. This is a constant that's infinite. This is a defined value of 1 mole. 1 mole, again, is going to equal to 179.87 grams, 5 sig figs. So 3 versus infinity versus 5. 3 is going to be how we round the answer. So your final answer will be rounded to 0.136 grams of iron nitrate. Finally, the question is how many moles of iron nitrate are in 0.407 grams of this sample. So once again, thinking about this, you're given a gram amount here. We're being asked for a mole amount. All we need to apply is molar mass. So let's make it happen. 0.407 grams of iron nitrate. Go ahead and apply the molar mass. The molar mass is still the same as before. This time though, because the units have to match off, cancel off anyway, to where we match them diagonally, we're going to put grams of iron nitrate on the bottom for every 1 mole of iron nitrate on top, specific to this compound. Once again, grams and grams go away. What you're left with is moles, which is the goal unit and the right substance. So we go ahead and stick that in your calculator, and you get 0.00226 moles of iron nitrate. Again, keeping track of our significant figures. All right, so reminder 3 here. This is 5 here. This is infinite. That's an infinite. So 3 significant figures. These first 2 are never significant. So 2, 2, 6. That's 3 significant figures. Maybe we rounded it again to be 6 at the end there. All right, that'll do it.